Previously, we talked a lot about capacitor inductors, and we haven't discussed this one yet. But however, I just skip to here first. So managing of op-amp is typically a lot of op-amps applications. As you can see, there is so many. So in this video, I'll talk about positive feedback and negative feedback, and what is actually op-amp. And then subsequent videos will talk about the rest. So in this so what is op-amp is that there will be there is a non-inverting point, then there is an inverting point. There will be a supplying into this op-amp, and there will be a V out. So in this case, this is just an op-amp itself only, and there will be two rules for an op-amp. So the first rule states that no current flows in or out of the op-amp, meaning there will be no current that flows into this op-amp or flowing out of these op-amps. Okay, so this op-amp is free of current. So this is another. So if you don't believe in it, there is actually later I'll talk about it. This is a op-amp ammeter. Okay, so there will be a 0 ampere inside here, right? So because there is no current flowing into the op-amp, all the current will flow into some meter. So it's a thing that you need to know. So if it's a closed loop system, right, meaning if your V out is gonna feedback to your either your non-inverting side or your inverting side, your op-amp will try to keep the voltage between these two pins the same. Okay, so this is the two rules that you're gonna remember. Hopefully you can remember. Okay, so go through op-amp. So what is non-inverting and inverting amplifier? So in an amplifier, okay, I think I have to go through this one also. So if it's a positive feedback, okay, you have a schmitt trigger. Okay, it's a noise. It have noise immunity by reducing the spikes when input has certain noise. Okay, so if it's a positive feedback, meaning you're gonna close loop. So you're gonna close loop this output into the non-inverting side, which is the positive side, right? So this is a positive feedback. Okay, you're connecting closed loop feedback to the positive side. If you're gonna feedback to the negative side, you're gonna create an amplifier, right? You're gonna create an amplifier. Okay. So for amplifier, you'll talk about gain bandwidth already. So later we'll talk about it. So nonetheless, positive feedback you'll talk about use for ADC component. Positive feedback, if you were to take a look, positive feedback is always ADC. This is actually a flash ADC, okay? This is actually a flash ADC. And in fact, there is no positive feedback actually, in some sense, because they're actually open circuit. I mean open loop, meaning that only V in and V reference go in only. But nonetheless, you may also need to take note that where am I? That positive feedback will also be used for ADC component. However, for flash ADC, right? If you remember, this is flash ADC configuration. You will know that because the V in, this V in are all series. They're connected in series. And then this V reference is also connected in series. So this is why you can actually create a list of things. Let's say 7 volt, 6 volt, 5 volt. You can actually create a potential difference between resistors. So this, when you're connecting in series, then you can do that. If it's a parallel, voltage are all the same. If you remember the voltage divider rule. So this is the first key thing that I want to give you an understanding. And nonetheless, for positive or negative feedback, you can also use for DAC, digital analog converter. Because you know that digital analog meaning you're going to connect all the digitals wherever electronic side and change it to analog. So it's less tedious in the case. Maybe you should hold on. As you can see, this is actually a DAC, digital to analog converter of an op-amp. So you connect things in I think I explained already, so you can watch that video. But they are connected in parallel. and then you connect it into the inverting side, right? And then you have an output of inverting phenomenon. Nonetheless, you can also connect it to the positive side. So it's whether you want it to be inverted signal or non-inverted signal. It all depends on whether how you want to connect it. So it is simply the case because actually DAC in this scenario are all connected in inverting. Okay, as you can see in the notes, they are connected in inverting side. But however, you only have a negative output. You have a negative gain in a certain sense. So I believe that DAC can also be connected in positive side also. So this is a thing that yeah, I might not explain it now. So yeah, so let's go back to where we are. Where are we? I mean where we left off. So positive feedback and negative feedback. So now let's talk about negative feedback. Since you already know that positive feedback is just a noise immunity and apply for ADC component, that's all. These are the two things that you need to know. Alright. And then negative feedback you need to know amplifier. Okay, negative feedback is always amplifier. So if you were to take a look in this scenario, okay, a a simple op amp, okay, a simple op amp, as you can see, the V in, the difference between, this is actually non-inverting, okay, this is non-inverting, and this is inverting amplifier. Non-inverting amplifier, you put your V source, your V voltage into the non-inverting side, while the inverting amplifier, you put a voltage into the inverting side, right? But the similarity between them, okay, if I were to close, like bring out the V in, as you can see, they are both the same configurations. They are both amplifying. Okay, the way you connect the resistors and this resistors over here is to amplify. All right, as you can see, this is the equations uses two resistors. In other words, this is actually R2 and this is R1. Similarly, this is also R2 and this is R1. So if you have a non-inverting side, if you connect a voltage into this amplifier op amp, okay, you're gonna have a R2 divided by R1 plus 1 gain. This is actually a gain. Okay. So if this is 5 ohm, and this is 1 ohm, you have a gain of 5 plus 1, right? 5 over 1, because this is 1 ohm, plus 1, you have a 6 gain, right? So this is the keynotes for inverting and non-inverting amplifier. So this, let me repeat again, is that you have a V in into the positive source, into the non-inverting side lah, they call it, and then you have a V into the inverting side. But take note that amplifier always have to close feedback to the negative side. Amplifier always feedback to the negative side. So negative feedback, amplifier, negative feedback, amplifier. Okay, this is how it goes. So if you were to take a look in this scenario, there's a little slightly more hairier explanation. So okay, never mind. I'll just build on this one. This is really hairy. So if you have a thing that is grounded, okay, you have a grounded. This is also a non-inverting amplifier. Okay. Likewise, if you have something that is grounded, this is an inverting amplifier. So whether grounded or not grounded, as long as you can see there's a V in whatever it is in either one of them, you know that it is either non-inverting or inverting. Right. So this can be the scenario. So as you can see, there is a 6 volt over here. Right, there is a 6 volt into the inverting side. And good job. I don't know why this also have a 6 volt into the positive side. Shouldn't have. As you can see, this is a slightly better one. So inverting side, as you can see, the 6 volt it goes into the inverting side, while the non-inverting one is 0 volt. So you're referencing to grounding, that's all. So as you can see, this is the trend itself. Right. Let me repeat again. So the 6-volt source, okay, is connected into the inverting side, and then as you can see, the positive side is 0. So if you have a source connected into the negative side, you know that is an inverting amplifier. Okay, you can see that there's a closed loop. Okay, closed loop back into this inverting side. Okay, and nonetheless, I am wrong. Okay, this is actually some good stuff. Yeah. So this 6-volt itself is a source. Okay, it's a power source. So this power source is fed into the positive side, right? It's fed into the positive side. So why is there a 6-volt over here? As you can see, there is no supply source also over here. But why is there a 6-volt? The reason behind why is there a 6-volt is because if you remember our op-amp rule, if it's a closed loop, okay, if it's a closed loop, the op-amp tries to keep the voltage between the two pins the same, right? They try to keep the two pins between the two pins the same. So if you supply a 6-volt, this dude gonna feedback to this op-amp, saying that okay, you must have a 6-volt over here also. So you have a 6-volt and 6-volt over here, right? So this is how the op-amp works. If you take a look in the inverting side, if you supply a 6-volt over here, but however the positive side is 0-volt also, because there is no feed, as you can see, the positive side has no feedback at all, right? It's straight away connected to ground. So if you want to ensure that your op-amp shares the same voltage, this is why um, the feedback is also 0 volts, right? This is why this feedback is 0 volts, because they want this feedback wants to be the same voltage as the positive side. This is the rule of the op-amp lah, okay? So the 6-volt itself is just to connect, and then yeah, yeah, the 6-volt is just a power source lah, and then you want to amplify or not is your business lah. So in other words, whether is this one the same as this one is totally you need to take note only, but it's really irrelevant in our case. Okay, it's just a good note. Maybe like trick question you may know how to do. So let me see. There is two ways you can know how to do gain bandwidth. One way is to you go to this video and then you watch it. Okay, and then another way is that yeah, I just do it now. So imagine you have a okay, so maybe I should draw. So you remember your op-amp, ideal op-amp case, right? Your ideal op-amp has to be infinite. If ideally you have to be infinitely high, right? Has to be yeah, the gain bandwidth has to be the gain and the bandwidth has to be infinitely high, right? As high as possible. So in this case, ideal op-amp is like infinity lah for gain bandwidth. However, for realistic systems, let's say our gain bandwidth is 70 dB. Okay, this is exactly the same thing written over here, right? I just translate only. Okay, so sorry, yeah, it's 10 to the power 7. What's that? 10 to the power 7 hertz lah. Okay, in terms of frequency. So your gain bandwidth product is actually 10 to the power 7. If your gain is equals to 0. Okay? So let's say if you have a gain of, let's say 60 decibel. Okay, this is everything is in terms of decibels. If you want to know how to convert from gain to decibels, this is the formula 20 log gain. Okay, if you know that gain is actually V out over V in, right? So gain is just some values like if you still remember. So if my gain is let's say 5, right? So you'll be like 20 log 5. You'll get your things in decibels. So if you want to calculate what is the gain for 60 decibels, what you can actually do is actually to use this formula. In order to change from your gain to your decibels, you can use this formula, right? So in other words, alternatively, you can actually find your gain using your bandwidth thing. So how does this works? Okay, so if you were to use the formula given in this situation, this is your gain bandwidth in terms of decibel. I mean your band. This is your gain in terms of decibel. So in this case, if you are given a gain of 60 dB, so you can just straight away use this formula. 20 is the standard one. So if you were to do that, you will have 10 to the power of 3, which is 1000. So your gain itself is 1000, right? Meaning your V out over V in, it's 1000 gain. So this is exactly what it means. Alright. So how do you draw your thing over here? You have 1000 gain over here. Okay. So first step first, normally you're given a decibel. What am I doing? If you are given a decibel, change to gain. Okay, change to gain 1000 gain. So it's 10 to the power of 3. Gain bandwidth means what? Gain bandwidth product by definition is taking your gain times your bandwidth, you get your gain bandwidth. Right? So you know that your gain bandwidth is 10 to the power of 7 Hertz. So you know that your gain is 10 cube. You know your gain bandwidth is 10 to the power of 7. You can just bring this dude down over there and you can calculate your bandwidth, which is 10 to the power of 4. Right? So first step first, you need to change to gain first, and then you apply the gain bandwidth formula. Nonetheless, you also need to know which parameter. So gain bandwidth, you need to either know two of the things. Either your gain, your bandwidth, or your gain bandwidth. Either this one, or this one, or this one, or this one, or whatever, you know. So 2 out of 3 you need to know in order to solve your solution. So how do I get, so once I know my bandwidth already, okay, you know your bandwidth is 10 to the power of 4, which is somewhere over here. So this is where your frequency of your gain is. Okay, if your gain is 1000 gain, your frequency is 10 to the power of 4, right? So if you were to draw it down, you have a graph like this, right? This is a plot of your gain and your frequency. So this plot, if you were to plot it out, you also have to label some things. You're gonna label this as minus 3 dB, right? This is the typical standard one, or minus 30% of your gain, or 29%, okay, whatever lah. Okay, this is, but I think I recommend you say negative 3 dB lah. Okay, and then this is actually negative 20 dB per decade. So you need to label all this, and then you also need to label your gain, label your frequency axis, and then you also have to label this is pass band, this is stop band. Stop band means that you're gonna stop the gain. Okay, pass band, it means you pass all the gain now. And then what other stuff you need to do? And then you label your 60 dB or 1000 gain or whatever over here. So these are the things for gain bandwidth. So if you were to see, gain bandwidth is very similar to your what's that called? High pass or low pass filter, if you remember. Your high pass or low pass filter, you're plotting against frequency with voltage. In our case, gain bandwidth is gain and frequency. So just to repeat again, gain bandwidth, you need to take gain times bandwidth. Now typically bandwidth is the frequency, then gain bandwidth is also the frequency. So just another key thing is that along any of this thing, right, the gain bandwidth is always the same, 10 to the power of 7. Alright, 10 to the power of 7. So as your gain increases, your bandwidth will somewhat go smaller. Right, your gain is smaller, as you can see, your bandwidth is actually then big, 10 to the power of 7. So the bandwidth is to say that what is the allowable amount of bandwidth you can take before it reaches the maximum gain bandwidth. So along this line, the product of gain bandwidth, right, this whole line, the product of gain bandwidth is always 10 to the power of 7. So this is another thing you need to do. So I think I'll just call it. So just to recap back, we have talked about positive feedback, negative feedback. And these are the things that we talk about. ADC, you can go to another video, you can talk about. I have some discussion. If you remember, Anyway, so next video I'll try to talk about generator and then active filter and such. I think I'll talk about this first now. So I'll see you there.